Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment. Today we will discuss about methods to assess impact on soils, land and geology. They are important components of EIA. They also play an important role within other impact assessments such as when you assess water, ecology, ecosystem services, livelihoods, health, resource efficiency and so on. We may also note that now conservation and management of soils, land and geology is given significant importance within the United Nations Sustainable Development Goals, SDGs. The SDGs entered into force in January 2016. We see that soils and land appear in several of the SDGs. You see these concerns in goals 2, 12 and 15. Because of this, such targets apply to all countries. Looking at the legislations and legal applications within soil protection and conservation, most countries have laws and controlling procedure for protection of land. In particular, the development which displaces soil and converts land from agriculture or forestry to urban use or infrastructure. Further, we see that for contaminated land, development activities can introduce new receptors, means new receptors which can get contaminated through the contaminated land. For example, housing block can bring occupant as new receptor and there can be blockage to the contaminated land that can be created by development activities such as removal of soil from the contaminated place or soil replacement at that contaminated land. Therefore, whenever development is proposed, it is important to assess whether the changes introduced by the development will be significant or not. Development has the potential to convert contaminated land to uncontaminated land, and also it has potential to convert uncontaminated land to contaminated land. And it might not really change the chemistry of the ground at the depth. So accordingly, our coverage will include definitions and concepts where we will look at geology and geomorphology, land, soil, soil properties, soil profile, classification, structure, color, fertility and land evaluation. Further, we will look into methods in the scoping stage, and then we will look into methods for impact prediction. So, that will be our coverage, and accordingly our learning outcomes, the expected learning outcomes from you after completion of this session will include that you should be able to define and explain the concepts geology and geomorphology, and you should be able to define land, soil, differentiate between them, should be able to define soil properties, soil profile, classification, structure, color and so on. You should be able to list and identify various methods used in scoping stages, particularly at the desk study, field survey, laboratory work. Further, you should be able to list and choose various methods for impact prediction on land and soil, such as temporary land take and soil displacement, permanent land take and soil displacement, damages to soil structure, soil pollution and critical load, so on. So, moving on to definitions and concepts. Let us first see geology and geomorphology. Geology is a vast and complex subject, and only a few aspects which we really see in EIA process. Surface geology concerns superficial deposits such as drift, glacier deposits, river, gravel, while when we see solid geology only concerns pre-superficial formations. A number of aspects of geology are of direct importance in AIA process, such as conservation, protection and management of fossils, stratigraphy, minerals or other geological features which are of concern. The underlying geology has engineering and construction implications and affects both geochemistry and geophysics. Some geological aspects are of indirect importance in assessment. For example, both the storage and movement of the ground and surface water and water geochemistry, these all are influenced, as we had also seen in water chapter. It also influences the potential for on-site and off-site pollution as a result of development, and it also influences the pathways for any pollution that may have occurred in the path. Geomorphology includes the study of topography, the terrain, and includes the nature of rock and soils in relation to the erosion and deposition caused by glacier, river and wind. We see that human impacts can include landscape visual aspects, but also their consequences such as erosion, slope failure can happen, subsidence can happen, sedimentation in aquatic systems can happen. Some aspects of geomorphology such as soil erosions also overlap with soil studies. Further, now we will look into land and soil. Land and soil are often considered to be same things. So, they are sometimes taken as same, but there is an important difference between these terms. The quality of land for agriculture and forestry is determined by the combined physical properties of climate, topography and soil, whereas the value placed on land also has social and economic dimensions which are influenced by the potential uses of land and also the location where the land is located in relation to the settlements. You may reflect soil has many purposes for us humans. The productive value of soil is determined by number of important physical and chemical properties. An appreciation of the development's impact on soil requires an understanding of basic soil properties. So, we will look at the soil properties. So, we see here the summary of key soil properties like you see the texture, you see the clay content, coarse fragments, bulk density, pH value, depth, and then you also look at volumetric water content, plant available and then the water capacity accordingly. Then we also see the saturated hydraulic conductivity, electrical conductivity, aggregate stability and so on. The soil profile and soil classification. It is important to know the type of soil in the study area. A pit dug helps to understand topsoil and the subsoil layers, such as vertical section is called a soil profile and each individual layer is called a horizon. Two different soil profiles are shown as you can see in the image. Not all these subsoil horizons are always present and the horizons are frequently subdivided. So, you also see subdivisions within the horizons. Here you may note the profile of a typical spodosol. These types occurs more in cold and wet higher ground on wide and relatively flat interfluids and in low lying receiving sites. They can occur in some freely drained sandy parent material, low in nutrients in lowland areas. Their typical vegetation cover is coniferous forest. Here you may note profile of a typical oxysol as specified. These soils are highly weathered, forming in tropical zones with hot and wet moist climates. They are typical soils of tropical rainforest. Oxysols have low nutrient status but are well drained and suitable for agriculture production, where fertilizers inputs are available and can be managed in a way that maintains ecosystem services. Now, looking at the soil structure. In most soils, the soil particles or separates are organized into aggregates. Soil structures called beds vary in size and shape. Each soil horizon in a soil type usually contains type of texture and one shape and size of structure, but structure frequently varies with the depth. For example, angular and mainly subangular blocky structures in loams become coarser with the depth as you go deeper. Moving on, we see soil color. Field observation of color can be clue to soil composition, like after seeing the color you can tell what's the soil composition, parent material and soil drainage status, like how is the drainage in that particular area. Soil charts provide standard examples of normal range of soil colors. Now, looking at the soil fertility, two major soil chemistry issues that are of importance in an EIA are low soil fertility and toxicity, both of which will lead to poor plant growth. Low soil fertility is due to the low level of nutrients, so there's nutrient level is very low. For example, nitrogen, phosphorus, potassium and magnesium are low in the soil, or they are being made unavailable for plant uptake. Next we see soil toxicity. It is caused by high level of toxic elements or compounds being present in the soil, usually as a result of human activities such as spraying of pesticides, deposition of industrial waste, fuel spillage and spreading of farm manure, slurries and sewage sludge. So, because of that the soil toxicity can increase in levels. Further, we see land quality has two meanings when we look at EIA practice. First, it relates to the quality of undisturbed land and natural soils, their value for agriculture and forestry, and the provision of terrestrial ecosystem services. So, what quality does it offers? Secondly, we look at the degree to which soils have been degraded and polluted by the disturbances and contamination arising from human activities. So, what's the level of disturbance, and then the necessary remedial measures. So, what kind of interventions we need to take. So, while doing land evaluation, we focus on natural land quality, primarily the physical properties which cannot be changed by land management. So far in the evaluation process, land use planning purpose, the focus has been on estimating relative productive value of different areas of land for agriculture and forestry. So, we just take the productive value. The concept of sustainable development has introduced the need to protect the other functions of the soil. So, not just the productive value, but you also need to look at the other functions of the soil within the hydrological and carbon cycles, supporting habitats and biodiversity and maintaining terrestrial ecosystem services. Now, let us see physical land evaluation methodology. We find Land Capability Classification LCC developed by United States Department of Agriculture USDA. It classifies land quality according to long-term climatic, topographic and soil limitation to agriculture. So, that is one classification which is available for usage while classification purpose. Other we see is by FAO. FAO has developed evaluation methodology combining physical and social economic land evaluation, which also considers social and economic factors and the overarching concept of sustainability. So, it has much more aspects than what we see in the LLC developed by United States. Moving on, now let us look at how to go about scoping and baseline studies for the domain, particular domain. At this stage, you will decide, like you are scoping, you are seeing what all kind of studies have to be done. So, you will decide what all study has to be done and to what extent it has to be done, or what details the study has to undertake. At this stage, you will essentially decide if you are going to undertake a desk study work from your computer or report, or will undertake strategic field survey, go to field and look at selective things, or you have to undertake detailed field survey and also undertake few laboratory analysis of soils if required. Usually at this stage of scoping, when you may take site visits, it will be brief, it will be short site visits involving walkover surveys with your team to identify possible impact of development. So, you will look around and see what kind of possible impact can happen. For the site visit, you may require the understanding of geology, geomorphology, land use and soils. You may assess impact on landscape. You may also look at the visual impacts on water and ecology. While undertaking scoping, the most important aspect you need to consider is the significance of the impact. So, you need to look at how significant whatever impact you are predicting is going to happen. You need to see whether the geological or soil resources within a project's impact area will have significant impact, and if yes, then what are doable measures which can be undertaken to mitigate, reduce the predicted impact. Whenever you predict significant impact on land or soil, you may also consider taking a land capability classification or undertake a land evaluation, as you have seen. You need to identify where soils need to be conserved in order to restore the land. So, you need to identify those areas. For example, soil restoration is usually planned for mineral extraction sites. So, you do the restoration programs. You may also look at the possibility of developing landscaping in your project. In your field survey, you should include an assessment of quantity of topsoil and subsoil available. Wherever you anticipate contamination, you need to undertake appropriate site investigation. Let us see very briefly to the case example of Sacramento Weir widening project in Sacramento County, California. The U.S. Army Corps of Engineers and its non-federal partners, the State of California Central Valley Flood Protection Board and Sacramento Area Flood Control Agency, proposed to widen the Sacramento Weir and bypass by constructing a new weir structure extending approximately 1,500 feet upstream from the existing weir. So, this example is given to you as a reading. This environmental impact statement describes the environmental resources in the project area, evaluates the direct, indirect and cumulative environmental effects of 3 alternatives. So, it is also looking at the alternatives including no action alternatives and describes avoidance, minimization and compensation measures. Most potential adverse effects could be either short term or would be avoided or reduced using best management practices. So, we see that the effects and mitigation measures of the proposed action under the following titles. So, you can see how they have identified all mitigation measures under various headings. So, you can look at the geological resource, you can look at the land use, hydrology and hydraulics and so on. Moving on further, while you undertake desk study, you will be required to review and understand the existing data on geology, geomorphology, soils, land quality and also site history and local climate. This will allow you to have a comprehensive understanding of the state and the potential impact. You may also look around nearby areas for possible contamination of the land. We may note that geological maps range in area and details they cover. In order to cover large areas as a whole continent, you may look at geological map of scale 1:20 million. For regional maps, you can look at maps of scale 1:1 million and 1:250,000 scale. For more detail, you may cover 1:10,000 scale. So, all these scales are available. So, as per your requirement, you can look at those maps. You may note that for maps of areas of special interest to geologists, you may find the following sources. So, this list has been provided to you. So, you can see that at the international level, you have one geology portal, US Geology Survey. You can see here the web link is provided to you and the entire reference is given to you for this purpose. Then you see mineral resource and geology, again at the international level. You can see here. You can access these websites and then you can access this information. Then you can also see Aster Global Digital Elevation Map, which can be acquired again at the international level. In India, if you want to cover India, you have Geological Survey of India, from where you can acquire the data. In Indian context, you may also find data from Bhuvan National Hydrology Project. In Australia, similarly, you can see Australian Geoscience Information Network. Likewise, in Canada, you have Geological Survey of Canada. Likewise, in Canada, you have Geological Survey of Canada. Similarly, in South Africa, you have Council for Geoscience, CGS. So, you can also see British Geological Survey at the international level. Likewise, you can see Ordnance Survey, OS Terrain 50, Digital Terrain Model for which covers United Kingdom, UK. So, you can see here you have US Geological Survey, which covers only USA. So, you saw a range of sources which are available, free data is available for analysis. These maps can be used in combination with geological and soil maps. Topographical data and digital terrain models can be created to understand the geomorphology of your study area. We see that generalized medium to small scale mapping is required, that is from 1:50,000 to 1:1 million scale may be appropriate for use in studies involving larger areas. When you are studying larger areas, for example, when you are studying pipeline or electricity transmission line, so on. So, you can create maps at that scale, but when you study a smaller area, then these might be not that useful. Then you might need detailed and precise pictures for the purpose. And I have given these sources in the chapter reading. Let us familiarize ourselves with two kinds of maps in particular. We see solid maps. Solid maps show only pre-quaternary rocks, whereas drift maps show superficial quaternary deposits that have been laid down more recently after being moved by wind, water or ice. It is suggested that the drift maps provide much considerable information on soil and parent material in the survey area. Now, looking at the desktop study for land and soils. So, when you do desktop study, you first look into the information which are available and the usefulness of the information. You may be mindful that the scope, how usable the data may be for you, or its quality at different level, national and local scale. There can be difference in that. So, how useful is that data for you? You might find a lot of published sources, however, they are all not directly applicable to your proposed project, but they do give you a direction in which you further need to find out. There are a range of data sources for land cover and soil map as well. For example, ISRI SeaWorld soil information shows the distribution of individual soil types using either the USDA or World Reference Base classification. plus other soil characteristics including pH, bulk density, organic carbon and sand, silt, clay content and so on. And you need to be very cautious about what information you are looking for and how you want to apply and what scale you want to use it in. There are certain examples which are given at the international level and the continent level and different countries level, which data are available for analysis purpose. So, we see Food and Agriculture Organization FAO has soil portal at the international region. Likewise, you see the soil grids of 1 kilometer international level as well as national and regional level. It's WebGIS, it gives you information. Likewise, you can see ISRIC soil grids of 250 meter, WebGIS for the coverage is for Africa. Then likewise, you can see for Australia, you can see for Europe, soil data center. Then you can look at the United States. All these references have been provided to you in the chapter reading. You can see India. India has Department of Space, Indian Space Research Organization, ISRO, from where you can avail data. So, now moving on, desktop study for contaminated land. We will look into that. You would first check the possibility of contaminated land on the basis of the land use history. So, you might look at the secondary data and like to look at what the land history has been, land use history has been. You may get historic maps wherever available. In some countries, historic land use data is commercially as well as environmental data are available from regulatory bodies. You may also approach regulatory bodies for geological and hydrological maps. This is an important information. Looking at the history and the other context, it helps you to develop initial conceptual site model. You see that in New South Wales government in Australia and DEFRA and Environmental Agency in UK have produced guidelines on carrying out a preliminary survey of potential contaminated site. So, they give you a guideline, so you can look at those guidelines how to undertake these preliminary study. You may know that type, what type of contamination and to what extent does it occurs in the site, how far the land is contaminated on a site will depend upon the previous uses of the site. The operational process, what process had been undertaken by the previous users and the effectiveness of environmental protection measures adopted by them. So, how their processes were, so that all will determine the contamination level and extent in your site. You may also check for any possibility of pollution of subsurface or neighboring plot because they can travel into your study area. So, you need to ensure to record all possible activities and management practices adopted and type of chemical used on site and around the site, not only on site, but around the site. No matter how intensive your study is, there might be some limitations which you should record in your baseline assessment. There are numerous professional bodies that maintain data on type of material and chemicals that are used to wide range of commercial activities and also publish it. So, you can look at Society for Chemical Industry, Construction Industry Research and Information, and also EPA Environmental Protection Agency. So, they also provide data, guidelines and procedure for gathering information concerning previous land uses and potential contamination. Now, moving on to the field survey, you would be required to collect baseline information on land and soil from field survey. Information such as land forms, soil types, land quality, ground cover, land cover and tenure. You may compile these information into GIS for spatial and statistical analysis. Moreover, it is important to use of land in the study of the area. Further, in order to study soil, you may take note of from where samples are to be taken. You may prepare the sample network and density so that it represents the soil variations within survey area. References for the detailed soil survey methods and detailed statistical methods are provided you in the link. Some geological and geomorphology can be complex with variation in small areas. This may create challenge for soil surveyors. For purpose of field observation, you may use a soil auger to take samples from sequential distances within a soil profile. So, we see that as per the international best practices for EIA, it is required that land, soil and water are considered as natural resource and should be dealt in totality. Therefore, whenever you investigate, you should try to identify contamination that might exist in 3 phases like soil, liquid as well as vapor. So, you look into all these when you look at the contamination, and the countries provide guidelines on this. So, that is there, and you may look at the international guidelines on soil quality and sampling in ISO 18400 series of document. You would be required to hire suitable qualified person to undertake all land contamination studies, investigation and risk assessment. Also, an experienced practitioner will help you to identify health, safety and environmental risk from potentially contaminated site. So, you may facilitate digging for soil pits to observe soil structure and extent of crop rooting in each of the main soil types. For the purpose of surface mines, topsoils and subsoil resources maps are obtained from soil survey. So, when you make a detailed soil map, it is usually shown in the scale of 1:10,000 and they can be interpreted with reasonable degree of precision. So, those maps you can make. You may be able to measure soil properties through the soil depth. You can also look at other properties just by estimation by eye. You can also use quantified standard techniques for the purpose, and these all your decision will depend on the degree of precision required for the purpose. So, what precision you are requiring. So, you can use very simple things like, for example, simple sieve and weighing scales can be used for estimating stone content. Soil texture can be determined by hand, but would need experience. You might also require adjustment with standard samples. Also may need laboratory analysis. You should identify soil resources that would be required for conservation and land restoration. Your survey should provide information on soil depth, volume and physical characteristic of available topsoil, subsoil, soil formation material, and also the description of original landform and drainage. So, whenever you prepare the reporting, you give these information. Looking at now survey of the contaminated sites, if during the desktop study you find possibility of land contamination, then you can take walk over survey to identify stretch to find out whether the further investigation is required or not. Such observations are important for scoping studies. You may not need it for initial project planning stages unless desktop study suggests of the risk. So, only if it is suggested, then only you may take when you gather from your desk study. Now, moving on, we will look at the laboratory work. So, if the project requires greater precision, so if you need information of greater precision in the information of grading of the land quality, then you may go for the lab evaluation. For example, analysis of soil texture and pH. Lab analysis are expensive, so only when it is required you undertake that. And also lab study are taken at very number of stages in the EIA process. It is taken at the baseline study level as well for land evaluation. It is also taken at the mitigation measure level to decide what kind of treatment will be given. Also at the analysis is undertaken during the project construction and operation for monitoring and management purpose. So, you do take soil sample at different levels, different stages. So, measurement of contaminants. For meaningful assessment, it is essential that the soils are analyzed for all the contaminants potential in the ground within the site. Investigations of contaminated sites are often hindered by an incomplete understanding of the polluting activities. So, you need to take care of that. Moving on, we will now look at impact prediction methods. So, we will see that how the impacts are predicted. Mostly we do EIA within legal context of the country. So, based on that only we identify impact. You can see the guidelines given by MOEFCC, Government of India, which suggests some of the tools, frameworks for impact assessment for land environment. Many governments may consider mineral extraction as part of the sustainable development, and because it provides raw material to industries. So, the site, if not managed well, such mineral sites can result in groundwater pollution by leaches. There are significant seismic risk. Mining activities like hydraulic fracturing, fracking can lead to significant geological problems. There can be if we try to understand the fracking process, then it involves pumping liquids into. If we try to understand the fracking process, then it involves pumping liquid under pressure into rock formation to force shale gas out. In the process, the main geological risks are that expelled gas might contaminate the underground aquifer and may also cause small earthquakes. And then there is a larger risk of earthquake due to wastewater disposal by injection into deep wells. So, we can see one of the examples. There was earthquake of magnitude of 5.7 in central Oklahoma in United States in November 2011, which destroyed 14 homes and injured people. So, in some countries even volcanic risk is considered. You also need to look into subsidence and slope stability. So, there can be subsidence by underground mining and usually associated with traditional coalfield areas. And there can be issues with natural slope stability, which is very common. Your purpose in EIA would be to avoid the construction of new development in unstable areas. Reference to more information related to planning issues with regards to subsidence and slope stability is provided to you in the chapter reading. Road development can have direct impact on geology and geomorphology by displacing rocks and changing landform. It may also have indirect effects and might change the hydrology, such as diversion of streams. So, by the road the streams can get diverted, which eventually affects the recharging of the aquifer. Further, we see that it is extensively difficult to preserve geomorphological features, and best of these is to avoid the proposed development. Further, we see impact on land and soil, impact of our activities such as deforestation, poor planning and management of urban and industrial development lead to problems such as soil erosion, degradation due to loss. Also, poor environmental management and also inappropriate development causes permanent loss of land and soil, which could be avoided. So, whenever you start EIA, first you should identify the study area within which significant impacts are most likely to occur, and then you determine the appropriate temporal scope of duration of construction, operation and restoration phase. So, you look at all those things and then you predict the magnitude of the potential permanent and temporary impact of land, including displacement of soil. So, your assessment of land will be based on selected physical criteria. Your evaluation methodology should set out a range of quantified values as class limits for magnitudes and sensitivity categories. You can adjust these class limits as per the scale of the development project. So, there are numerous evaluation methodologies. You can see FAO guidelines for land evaluation which is given, which provides set of principles. You also see USDA also provides an outline how to carry out EIA. You need to calculate the temporary land take, pulled and soil displaced. When you are doing this, you need to see that how much temporary land is taken away or the soil is displaced, as well as you need to see how much the permanent land is taken away and the soil is displaced. You also need to take note of the soil erosion by wind and water, which is serious threat to soil resources. Most soil erosions occurs as a result of agricultural land management practices, and you will note that they are not subject to development planning controls, neither they fall in the scope of EIA. There are a number of predictive equations to estimate soil loss during erosions. You may find universal soil loss equation, which helps you to calculate water erosion assessment, and conservation helps you to plan your conservation. You will also find wind erosion prediction system like land management practices and crop rotation. You need to also estimate the damage to soil structure because of the construction activities, vehicles and machineries. Such damages lead to reduced infiltration, increased runoff and erosion. We see that UK government as well as United States government publish legislation and guidance in this regard. You need to estimate the soil pollution. There are two types of situation which we see in matter of soil pollution. First, where the site is already contaminated and a cleanup operation is required. Second, where pollution may be caused by the project itself. If you observe in the baseline survey that the ground below the site contains contaminants, a risk assessment based on the pollutant linkages like the source pathway receptor, which we had talked in the previous class also, model should be carried out to determine significance. Significance may be estimated in terms of risk to the receptors. The baseline should be substantial to inform the project activities. So, whatever assessment you do, it should inform the project activities. And take note that proposed project can have both positive and negative impact. You can also undertake qualitative risk assessment to establish pollutant linkages. You may use modeling to capture the pollutant path. Modeling technique, this is the list of modeling techniques which you can use here. You can assess the risk to human health by range of modeling tools such as contaminated land exposure assessment tool. You can look at USA based risk based correction action. And then there is another terminology which you would like to see, critical loads. Critical loads provide a means to estimate the vulnerability of land to atmospheric pollution. So, how much pollution it can take in relation to the receptor soil, geology, freshwater and vegetation. So, United Nations Economic Commission for Europe has specified critical loads for deposition into sensitive ecosystem, and a critical load database for United States is also available. All of the above impacts can have serious effects on soil, but the soil types outlined here will be affected to different extent by each. So, we have seen all of these. So, summarizing what we covered today, we looked at the definitions and concepts of geology, geomorphology, land, soil and so on. We also looked at methods in scoping stages, what we really use, what's the purpose and what are the different methods available to us. Similar way, we looked at the impact prediction and the methods, what we can take, and several tools which are available for the purpose. So, that's all for today. These were the references used, and these are the suggested watch and read because our coverage is very limited. So, you can read more if you are interested and explore further. Please feel free to ask questions. Let us know about any concerns you have, to share your opinions, experiences and suggestions. Looking forward to interacting and co-learning with you while exploring EIA. So, that's all for today. Thank you.